This video will help you find the domain of a rational function. All a rational function is a fractional expression. You may have a polynomial on the top, a polynomial on the bottom. You may just have a plain old number in the top, but this is an example of a rational function. The domain of a rational function includes all real numbers except the x values that make the denominator equal to 0. Remember, domain refers to the x values. Because we're talking about a fraction expression, we know we're not allowed to have 0 in the denominator. So we're going to have to do something to ensure that we don't get 0 in the denominator. So the domain of the rational function is all real numbers that don't give you a denominator equal to 0. We cannot divide by 0, so we need to exclude from the domain all x values that produce a 0 in the denominator. Well, how do you find that out? Well, one way to do it is to look at a t-chart. So here's my function. I'm going to put in whatever values of x I want and see what kind of y value I get. Recall that f of x and y are the same thing. So if I put 0 right here, a 0 minus 4 would be a negative 4 in the denominator. This gives me 1 over negative 4 as my y value. That's perfectly reasonable. Put 1 in. 1 minus 4 would be negative 3. This gives me 1 over negative 3. That's a perfectly reasonable y value. Put 2 in here. 2 minus 4 is negative 2. 1 over negative 2. So far, all the x values we thought about plugging in gave us reasonable y values. Still going to get a reasonable answer right here. 1 over 3 minus 4 is negative 1. This just really gives me negative 1. But when I put 4 in right here, 4 minus 4 is 0. This gives me 1 over 0. You cannot have 0 in the denominator. This would be undefined. So all these other values we chose were just fine. It was putting 4 in for x that created the 0 in the denominator. We can't have that. If I continue with this chart, if I put 5 in here, 5 minus 4 is 1, 1 over 1 is 1, so I'm back to having a reasonable value. All other numbers that I would plug into this t-chart are going to give me decent values for y. Here's my only problem. That's the number that's going to have to be thrown out. So we write our domain as set builder notation, all x such that x does not equal 4. So all other numbers for the domain are just fine. It's just that this number for x has to be thrown out. Well, do you have to do a t-chart all the time? No, there's a very easy way to find out what the domain is. And it's this. Because we don't want the denominator to equal 0, we're going to set the denominator equal to 0 to find out which values create the 0 denominator. Sounds kind of weird. We don't want the denominator equal to 0, so we set the denominator equal to 0. Well, we're just trying to find out which is the one that's going to cause the 0, so set it equal to 0 and solve. If you add 4 to both sides, that's how we get x equal to 4. So no, we're not going to do this t-chart thing all the time. All we're going to do is take the denominator and set it equal to 0. That's all you have to do. Does not matter what the numerator is. Set the denominator equal to 0 and solve. And whatever number we get from our solving is the one that gets thrown out. So let's look at a couple more examples. I have 5 over 3x minus 1. I don't care what the numerator is. I'm going to set the denominator equal to 0 and go through my solving. That's a plain old equation to solve. Add 1 to both sides, divide both sides by 3. I get x equals 1/3. That's the number that's getting thrown out. So this is my domain, all x such that x does not equal 1/3. Look at the numerator. It may have a variable in it, but it doesn't matter. I don't care what the numerator is. I'm taking the denominator and I'm setting it equal to 0. I do my simple solving steps, subtract 5 from both sides, and I get x equal to negative 5. That's the value that's going to be thrown out of the domain, and there it is written in set builder notation. You may have 2 factors in the denominator, and that's okay. We're going to set the whole denominator equal to 0, which I have right here. And because this is 2 factors multiplied together equal to 0, we're using the zero products property. So we set this one equal to 0, we set this one equal to 0, and then solve each of those simple equations. We get x equal to negative 5 on this one, x equal to 2 right here. So my domain is all x such that x is not allowed to equal negative 5 or 2. Here we have x squared in the denominator, so we take that denominator, set it equal to 0. We don't care what the numerator is. This is a quadratic equation. To solve a quadratic equation, recall that you must factor it, and I did, x minus 6 times x plus 1, and then this is just like the last one. Set that one equal to 0, set that one equal to 0, and solve. Add 6 to both sides here, subtract 1 from both sides here. Those are my two values that are being eliminated from the domain. So here's the domain. Domain equals all x such that x does not equal 6 or negative 1. Any other number can be put into this equation and get a reasonable answer for y. F of x equals x plus 3 over 36, so I would set the denominator equal to 0, which looks really weird because there's no variable here. 36 does not equal 0. So very simple. If the denominator does not contain a variable, then your domain is all real numbers. Since there is no variable in the denominator, the domain is all real numbers. So finding the domain of a rational function is just a matter of taking the denominator, set it equal to 0, and solve. If there is no variable in the denominator, then automatically the domain is all real numbers.